Hey everybody, it's Mick. Welcome to my shop. So in this video I'm going to be making this carriage stop that I've been wanting one for a while, and please excuse my filthy dirty lathe, but I was in the process of making something, quite a few very similar parts, and just got tired of just trying to, take the move the lathe to the measurement on the DRO. So I made myself a carriage stop, and it stops the carriage. So this was quite a challenging video, or a challenging project for me, and I learned a lot on it. It's simple, but at the end of the video, I'll walk you through my challenges and what I learned from it. I learned quite a lot, so it was a good little project. Anyway, let's get started. As with most projects, we're going to start over here on the bandsaw and cut a piece off of this stock that I had lying around, some sort of mystery metal. Looks like some sort of 1018, 10 something like that stock, just based on the surface finish. Anyway, going to cut this to a little over 2 inches long. It's about 1 inch thick and 1 3/4 inches wide. Let's get the coolant going here. Alright, as is standard practice, we're going to start by squaring up the stock in the middle. Use a piece of wire here, so get some even clamping. And let's see what kind of cutter I'm going to use for this. Alright, I haven't used this face mill, for lack of a better term, for a while. I was just noticing it's very kindly gives the insert on the side of it there. It's always one of the problems I have with these indexable tools, is so many of them don't tell you what insert they use. Alright, I'm going to turn on the air compressor. So I've got air for the lube cube, so it's going to get a little noisy here for a bit. I think what I'll do is I'll let it run before I start any of this, and then hopefully we don't get too much noise after that. Okay, I think I've got everything set up while that was running. Boy, replacing these 2032 batteries left and right today. The height gauge, the quill DRO, just goes to show you how long it's been since I've been out here. See if how the lube cube works over here. The one on the mill, or excuse me, the one on the lathe was kind of gummed up. Okay. Okay, not bad. If it's time to do something with these inserts. Yeah, actually that's not that great. Huh. Let's try a different cutter. Alright, I'm going to swap out the cutter. I'll bring you back when I'm done. Okay, I swapped out that face mill for my Metal Masters cutter, and let's try this one, see how it goes. Get the zero that out. All right, let's try it again. Get some room here so I can flip this piece around. Okay, I've got the part flipped around at a 90. I used a square to square it up. I'm going to do the other side now. Pretty nice finish. Alright, let's get this turned around for the next operation. Alright, we're ready to do the other side now, and we're going to take this down to 2 inches. Okay, we're on the 4th side, got it up on a parallel. I need to take quite a bit off of this side, so I'll get us started and then I'll finish it up. Okay, so I've got a block now that is 2 inches long by 1.5 inches wide, and now I need to perform the other operations on the other side. Here's a rough sketch of what this should end up looking like. So I'm doing this top part here first, so 2 inches, 1.5 inches wide that way. This dimension here I believe is 3/4, but I need to double check it because I think, let's see, 3.343. If I take a 1/4 inch, yeah, that should be fine. So yeah, so 3/4 inches there, and then I'll cut away this notch here, and then cut the 90 for the V-ways. This is a through hole for a bolt to go through and thread into the clamping part. And this is a threaded portion for the rod that will be hitting the carriage to stop it. So let's get this thing back in the lathe or in the mill and bring it down to 3/4 inch. Okay, I've got the bigger Metal Masters fly cutter in here, and we're going to take this down to 3/4 inch. So I'm going to just face off this, clean up this first side, flip it over, and take the rest of it off the other side. That did not go well. Maybe I need to bump up the speed here. Okay, let's see. I'm going to start with shallower depth of cut. I've got the workpiece set up in the vise again, and I've switched over to a 1/2 inch roughing in mill. Now I need to cut down this surface, leaving 3/4 inch here, and cut down 1/4 inch and mill out that section there. So I've got the DRO zeroed off and set so that I can return to this edge. So let's get busy with it. I've got this is a high-speed steel end mill, so I don't use it very often, but with the amount of material I'm taking off, I figured let's use the roughing end mill. Alright, start with just a light pass, couple thou. Okay, take that out and deburr it. I've got the bottom piece, the clamping piece of the material in the vise now, and I'm just going to clean up this face and then flip it around and machine the other sides. Alright, let's get this set up so we can finish it up. Well, major malfunction here. So this is what it's supposed to look like when it's clamped to the lathe ways. And it's supposed to have a V, the 90, cut out in here. But when I designed this, I did not take into account how deep this needed to be. So when this is mounted on the ways, this part here does not stick out far enough to hit the carriage. So it's not going to stop the carriage. Now, this face here would hit the screw that holds the wiper on the carriage, but I don't want that. So gonna go cut some more material and remake this part, and I think I'm also going to leave these thicker so I have a bit more substance. And I need to measure this time and see how much, but I'm probably going to need to come out to about somewhere around in here. So I'm not going to bore you with remaking it up to this point, but I'm going to go cut some material, remake it, and resume back at this point. Alright, after a bit of milling around, I'm back with new parts that are full size this time. Yeah, I actually did plan for these parts to be this size, but didn't really plan it out well, I guess. So anyway, we're back where we left off with some full-size parts, and now we will resume the rest of the machining to turn this into a carriage stock. And I guess I'll stick this in the scrap bin because I hate to throw anything away, and it might come in handy someday. Might. I've got a wiggler set up, and I'm going to use that to locate the bottom of the V here, because that's where the edge of the V groove that I'm going to cut is ending up. I've done some math. According to my math, see if we can see that there. Yeah, there. The V, the bottom, the hypotenuse is 0.7050 inches, which means that it goes to a depth of 0.3525, with each side being 0.4985 inches. And this right here represents where that point is that I am attempting to find now with the wiggler, so that I can set my DRO. Set the wiggler to straight. Too far. There we go. Alright, now that should be the point I want to find. Need to raise the head a little bit. We don't have enough room there. Think you can see. I'm going to move the camera. There we go. So that's the bottom of the V I'm trying to find. Let's see, keep my big fat hands out of the way. Ooh, that's pretty close. Okay, I'm using a brand new 4-flute carbide end mill. So if I go back to 0 now, which is right there, that should put the center of the end mill on the center of that V. So I need to move the table this direction 1/2 3/8. I'm going to be climb milling, but that's okay, because I'm going to take super small passes because I want to see what's going on here. Alright, let's try a foul to begin with. Okay, that's looking pretty good. And basically what I was just doing there is milling out part of the center of the V. So I'm going to move these x-axis over to the one face that needs to be, that'll be the one edge of the triangle. I'm going to loosen the locks, and I need to go Yes, that way. So we'll do, try a thou at a time. Alright, I'm not sure if this counter bore is going to work. It might be too big. Or too small, I mean. Alright, let's get started. Yeah. I'm going to do these 3, see how that goes, and see what I need to do. This is one of the reasons, right there, that I bought a square head mill instead of a round column, because I knew I was going to be moving the head up and down and messing up my alignment. Oh, what am I doing? Some good old anchor lube here. Alright, we're going to counter bore this 0.3. Let's see if the screw fits. It does a nut. It does a nut. Alright, looks like a 12mm end mill is the answer. I happen to have one because when I first started this hobby, I thought it would be useful to have metric stuff in addition to the SAE Imperial stuff. And so far that has not proven to be true very much, but now it's come in useful, hopefully. I'm using 5/16 cap screws, but I don't want to use a 5/16 counter bore because they just seem to leave such a bigger bore than is necessary. I want this to be tight so that doesn't constantly fill up with chips. And yes, I know I shouldn't be using the drill chuck for this, but I don't want to swap it out. So there's simple little operation. Alright, let's zero it out again. And then we're going to go down 0.3. I love brand new end mills. Nice and sharp. There we go. That's what we're talking about. Okay. Next. Drilling operations like this are when this quill wheel comes in really handy. You don't have to keep hunting for the lever. I do like it. If you want one, reach out to Jim Enos at Tangent Engineering. Good guy. He makes some pretty cool tools. And I tell you what, I helped him do the prototype for the Precision Matthews PM727s, and he is a stickler for tolerances and precision design. So even on this quill wheel, so I can only imagine how he is on some of his other tools, like his sign bars and lathe sign bars and things like that, is a burnishing wheel. Not a commercial, just a recommendation. Okay, need to deburr those. My favorite deburring tool, these are Vera countersinks on a, I have it on drill mode, or yeah, screwdriver mode. Almost had a major faux pas. Would have had to make that part over again, because I need the tap drill size for this now, which, according to Engineer's Black Book, is an F. Caught myself just in time. Alright, and this one needs to be a through hole. Well, it doesn't need to be, but it's going to be, because the bolts I have, cap screws I have, all go almost all the way through anyway. I want maximum clamping force. I do not want this thing to move. Alright, gonna go tap these. Alright, it just so happens that I do have a 5/16 spiral float tap for my tapping arm. There we go. She's locked in and ready to go. It's a little tight over here in this part of my garage because I've got unfinished projects. Back here in the background is the table that I have all the parts, the rest of the parts for the surface grinder on. So yeah, one of these days hopefully we'll get this cleaned up. And let's see how this sucker does. I think she went all the way through. Maybe not quite. Let's run her through once. Actually, I think I'm going to finish it up with a hand tap, just so in case I don't want to take a chance of getting it cross-threaded. Not doing that. All right. All right, there she is assembled. That turned out pretty good, I think. Got one more thing to do. I got to make a rod that comes out of the side here that sticks out for the actual stop. That part would be useful, huh? The actual stop part of it. Alright, we'll do that next. Alright, I've got a piece of stainless steel chucked up in the lathe here. I'm going to turn down for a threaded portion, and then we'll flip it around and finish it for the rod to make the stop for the carriage stop. put the soft jaws in so I don't mar my surface here. Got a little scratch on it already, but that'll polish out. Did I say polish? Ooh, foreshadowing. Okay, I think this should be the final milling operation. Just going to drill and tap a hole for the stop. I'm going to do this in 2 steps. I'm going to start it with tapping arm just to make sure it's straight, and then I'll finish it up because this tapers. So let's get some of our favorite anchor lube in there. One of these days I need to bolt this thing down here, or make it so I can bolt it down. One of the many projects on my lists. Okay. Okay, the final step. Let's get this cleaned up. Some acetone. I'm using Brownell's Oxbow Blue. This is my favorite bluing agent. I also use Jax, J-A-X, but that seems to work better in situations where you can submerge the part. The Oxbow Blue works better in a brush-on application. Okay, go rinse this off in some hot water, and then we'll oil it up and be done. Now I know some guys don't like bluing. Matty, from Matty's workshop in particular, I've heard him say that he doesn't care for bluing, but I think it's just a personal preference. I like it. I think it kind of finishes a part off. Of course, if you do the quality work he does with the finishes he gets, yeah, bluing probably is not necessary, because the smoother the finish, the less likely it is to rust, and his finishes are impeccable. Something to strive for. Alright, I'm going to let this sit a little bit, and then I'll wipe it off and assemble it, and we're done. So as I mentioned at the beginning of this video, this was a rather challenging video for me, or a rather challenging project, excuse me. Not because the machining was difficult. It wasn't really. The hardest part was cutting the V, and that was made more difficult because of the other things that I did wrong, or didn't do, I guess. It's a better way of saying it. And to sum up what I did or didn't do, and what I learned from this, it all came down to planning, measuring, drawing, and planning. And one of the things I didn't take into account when I started this project is that the top of my V-way here is flat. Well, I used a height gauge to measure that, and my first set of calculations and drawings did not take into account that that was flat. I also measured the width across the base, the hypotenuse of the triangle, and that, luckily, there is a flat on the back side here. The V doesn't go all the way down to the bed, so that measurement was better. But it all came down to that. I mean, even as you can see here, this part is different than when I finished it at the end of the video, because again, I didn't take into account this diameter of this stop would not fit underneath this lip on my carriage. It was literally just hitting it enough that I could force the carriage up over it, which then of course would screw up my cut and everything else. So as a fix, I just turned down this end of it to leave a shoulder that can fit underneath the apron there. All sorts of little things like that. I mean, you saw the first cut at this, and part of the reason for it is, again, planning, lack of planning. So what I learned from this is a couple things. Plan better, measure better, but also this might have been a good project for me to draw up in CAD and print a 3D prototype. You know, it seems like such a simple project, and the reason I did not do that is because I felt like it would be a waste of time. Well, it turns out it would not have been a waste of time, and would have saved me scrapping that material. So anyway, that was where the challenges lay. You know, a lot of the projects I do are standalone, or you know, tools that I build that don't rely on anything else, and fitting this to this with, you know, this V and everything just complicated it. So but that's what I learned, and that's the end of the project. So it's done, and it's time to move on with making the parts that I actually even wanted this for. So thanks for watching, and take care.